Hey guys, so this worksheet is putting the last two thoughts together. We're going to be solving a radical equation through algebraic methods, and then we're going to graph them using our technology so we can check that our answer is correct and that we don't have any sneaky extraneous solutions. So on your worksheet there are 4 questions. I am going to do the first one with you, and then the rest are for you to finish. So I left you a lot of space underneath the question. I think that's where you should do all your work for the algebraic method. So we have x minus 6 equals the square root of x plus 6. And because the radical is isolated, now would be a good time in your work to go ahead and square both sides. This is the most precarious part of your work because you have to be careful when you square the binomial that you distribute that like a FOIL question. So it might work out better for you if you rewrite it as x minus 6 times another x minus 6. And then obviously on the right side, the square root and square will undo each other and you just have an x plus 6. I'm going to go through the distribution and take as many steps as you need to simplify this, but we do end up with x squared, and then minus 6x, minus another 6x, and then negative 6 times negative 6 will give you a positive 36. So typically these questions produced quadratics when they were really tricky, and that's what we have going on here. So for our quadratic equation, you can use whatever method you want to solve, but we saw in our previous lesson that they typically factored very nicely. So I'm going to move everything over to the left side. I'm going to subtract the x over. I'm also going to subtract the 6 over. Be careful as you're collecting your like terms. Obviously this right side is going to be a 0, but when you are collecting your linear components, negative 6x minus x would be a negative 13x. So we end up with x squared minus 13x, and then combine your constants and you get a plus 30. There's our quadratic, and we are going to factor this. That is the best method for solving these. So I'm looking for 2 numbers. The back numbers have to multiply to positive 30. You need your arches to add up to negative 13. So a good combination there would be a negative 10 and a negative 3. But don't forget to solve. So if you were to solve each of your factors, here you would get x minus 10 equals 0, so x equals 10. And then here you would get x minus 3 equals 0, or x equals 3. However, we know that these produce often extraneous solutions. So what we're going to do next is go over to our technology, or you can graph by hand, where we type one side of the equation into y1, and then the other side of the equation into y2, and you can confirm the real solutions through the intersection method on your graphing utility or graphing by hand. So I have those typed into y1 and y2, and when I look at the graph in standard viewing window, these curves will only intersect at one spot. If you're not sure what that answer is, I would suggest you look at your work, or you can go to the calc menu and use the intersect feature to find the intersection point. And what do you know? X equals 10 is the solution. That is the real solution for this problem. Notice they did not intersect at x equals 3, which means if we tried to plug that into the algebra, we'd see that it was indeed an extraneous solution. So I want to see that you get it, but you're going to show me that it's extraneous by crossing it off and writing ext. Now, as far as what you're going to put on your paper here, and I'm not going to do this because I can't draw, I would like you to give a really ugly sketch, apparently, of what we have. And you're going to show me basically what you see on your calculator. Okay? The important part of this question is that you're utilizing your technology to check your answer, not necessarily to find the answer in the first place. The algebraic component is really important. I see this question a lot on the No Calculator SAT test. So I've even seen it where they say, when solving this radical equation, what extraneous solution shows up is actually a question that I've seen. So be careful about this question. It is real tricky on the SAT, but I wouldn't be surprised if you saw it on your No Calculator section. All right, that's probably enough to get you going. You got to do the next 3 questions on your own. Please do use your graphing utility and email me if you have any questions.